Okay, in this video I'm going to show you how to carry out a hypothesis test in SPSS, or more specifically I'm going to show you how to carry out a two-group t-test using SPSS. So right now I have open the NIS lab dataset. That's what I'll be using for this example. Now let's say I'm interested in studying the religious service attendance or the church attendance patterns of migrant men and migrant women. I want to know if there is a difference in mean religious service attendance by gender. So in order to do that, I need to structure this like a hypothesis test, like we talked about in class. So I need a null hypothesis, I need a research hypothesis, and I need an alpha level. So as some of you might remember, the null hypothesis is always inequality. It means it tells us essentially that there's no difference between the two groups. Whereas the alternative hypothesis, at least as far as a two-tailed test is concerned, is that there is a difference between the two groups. And generally speaking, in the social sciences, we use 0.05 as our alpha level. I'm actually writing all of this down in my notebook because it's something that helps me keep things straight as I'm carrying out this kind of data analysis. So I will go to Analyze, and I will go to Compare Means, and then down to Independent Samples t-test. You can see I've been playing around with this already. So I'm looking at church attendance. That's the number of times on average a person goes to church per week. And I want to group that by the sex of the respondent. And you can see here I've got sex there, but I have these two question marks here. So I'll click Define Groups, and when you open it, these will be blank. You'll just see Group 1 and Group 2. Now, this is where most students get lost as far as hypothesis testing is concerned. They'll think to themselves, well, I want to compare men versus women, so I will type men, or I will type females, or I will type women, but as you can see, nothing is showing up in those two boxes. You need to enter numerical values in those two boxes, so you need to remember how these two groups were coded. So as a refresher, you might want to close out of this. We'll be back in just a second. And we will remind ourselves as to how sex was coded in this particular data set. So we'll click on Variable View, and then we'll go over to Values and click on this box, and it will remind us, oh yeah, 0 is equal to females and 1 is equal to males. So I'm actually going to write that down in my notebook so I don't forget, and then I will click OK. I'll go back to where I was. So Analyze, Compare Means, and Independent Samples t-test. Again, saved my stuff from last time, so I will put church attendance back in there. I will put the sex of respondent in here. Now I'm going to define my group. So again, this will be blank when you first open it. So I'm going to remind SPSS that women were coded as 0 and men were coded as 1. That's not necessarily a reference to the relative worth of each gender, it's just how they were coded in this particular data set. Then I will click Continue, and now I have my two groups. Now SPSS knows essentially that we're comparing church attendance and we're doing it for women versus men. I click OK. It'll give me a summary of the group statistics here. Tells me the number of men, the number of women, gives me the mean church attendance per week as far as men and women are concerned, along with the standard deviation and the standard error. So it looks like there's a little bit of a difference, not much of one in terms of mean church attendance for men versus women. Looks like women are slightly more likely to be going to church in a given week. But we need to know, is this due to some kind of actual difference in the population, or is this due to sampling error? Did we happen to just get a bunch of atheist men and a few really pious women, and that's why we're seeing this difference? Or is there something more going on there? So to answer that question, we have to go down to this independent samples test box. Now there's a lot going on here. We have Levine's test for equality of variances, we have an F statistic, we have our T statistic, we have degrees of freedom. There's a lot going on there. But really what you want to focus on is this SIG two-tailed box. This is essentially your p-value, or in other words, it's the probability that the null hypothesis is true. So generally speaking, if the value in either of these boxes is less than 0.05, it means you get to reject your null hypothesis. In this case, really low numbers, zeros, are awesome because it means that there's something actually going on there. Whereas large numbers, anything greater than 0.05, means that we can't reject the null hypothesis, or it's essentially telling us that there is no difference between these two groups. So you see here, 0.88 in both cases is significantly larger than 0.05. So in this case, we can't reject our null hypothesis. We have to conclude that there really is no difference between these two groups. Now let's do another example. Let's do one where we actually get to reject our null hypothesis. So we'll go to Analyze, and then we'll go to Descriptive Statistics, and then we will go to, oh, I'm sorry, not Descriptive Statistics, we'll go to Compare Means, and then we will go to Independent Samples T-Test. Let's get rid of church attendance, and this time let's do years of school completed. Now let's do total family income. So we're going to see if there's a difference in terms of mean income between men and women in this survey. So we'll click OK. And again, we have our summary statistics. We have number of men, number of women. We have the mean for each group. It looks like there is some kind of a difference there. But again, it could just be due to sampling error. Maybe we got a bunch of really, really wealthy males and a bunch of really poor females in our sample, and so this difference that we're seeing is just due to sampling error. So again, we go down to our independent samples test box, and we go over to our two-tailed significance box, and again, if either of these two numbers is less than 0.05, it means that we get to reject the null hypothesis. It means there really is a difference. You can see here that both of these are greater than 0.05, which essentially tells us there is no difference. We can't reject our null hypothesis. So even though it looks like there's a difference, and boy does it, that's almost $18,000 difference between these two groups, we can't rule out the possibility that this difference is just due to sampling error. We have to accept the null hypothesis. Let's try one more time. Let's see if we can get one where we actually get to reject the null. So again, Analyze, and then down to Descriptive Statistics, Compare Means, and then to Independent Samples T-Test. We get rid of total family income, and this time we will do years of school completed. Should be a good one. And then click OK. So we have, again, our summary. Looks like there is a bit of a difference there, 12.79 years on average for women compared to 13.93 years on average for men. A little bit more variability amongst women, you can see from the larger standard deviation there. So now we go down to our SIG two-tailed box, and finally we have a number here that's less than 0.05. It's less than our alpha level, which means we finally get to reject our null hypothesis. We finally get to say, yes, this difference that we're seeing here, this is real. This represents an actual difference in our population. It's not just due to sampling error. We didn't just happen to sample a bunch of highly educated men, and that's why we're seeing this difference. In fact, because this is less than 0.05, we get to conclude that this difference is real. We reject the null hypothesis and say, yes, the research hypothesis is more likely to be true. Yeah, that should pretty much do it. If you have any questions, I realize this gets a little bit technical. So if you have any questions, please talk to me, talk to your instructor, talk to the course TA.